A special gas mixture used in bacterial growth chambers contains 1% by weight carbon dioxide and 99% by mass oxygen. What is the partial pressure if each of the gases at the total pressure is 0.911 atm? They want us to use the mole fraction definition of Dalton's law here. That's a capital oxygen, by the way. Where the partial pressure of carbon dioxide is equal to your total pressure times the mole fraction of carbon dioxide, and the same goes for oxygen. The question is, how do we get those mole fractions? How do we get the moles of each? Well, what we're going to do is mole fractions are ratios. So is a percent. The only problem is they gave us a percent by weight or by mass. So what we're going to do is we're going to change that percent by weight into percent by mole, or mole fraction rather. So we're going to assume 100 grams. And it doesn't matter, since we're taking a ratio, the amount we start off with doesn't matter. But if we assume that we have 100 grams, then that gives us 1 gram of carbon dioxide, and it gives us 99 grams of oxygen. So now we just need to figure out the moles of each. And 1 mole of carbon dioxide, I go to my periodic chart, 12.011 plus 2 times 15.9994 is 44.0098 grams, and that gives me a mole fraction of 0.02272 moles of carbon dioxide, not a mole fraction, my moles of carbon dioxide. Do the same thing for my moles of oxygen. 1 mole of oxygen is 15.9994 times 2 is 31.9988 grams of oxygen. 99 divided by 31, and that gives me 3.094 moles of oxygen. So in this mixture, my mole fraction of carbon dioxide would be 0.02272 divided by 3.094 plus 0.02272. That's a 0 there, by the way. That would give me whoops. That gives me, by the way, 3.117. Okay. 1 over x times 0.0227. And that gives me 0.00728 as my mole fraction of carbon dioxide. Now I'm going to repeat the process. Alright, let's keep going here. We've got 1 mole fraction. Let's get the other real quickly. Mole fraction oxygen, 3.094 moles of oxygen over our total moles from what we calculated last time, right? That little number we calculated last time. Equals 3.094 divided by 3.117. 0, oh, come on, 0.9926. So those are their mole fractions. Remember, our formula to get the partial pressure of each is simply the total pressure times that mole fraction. So I'm going to use that formula now. So I've got my mole fraction of carbon dioxide right there. Now I'm multiplying by my total pressure, which they gave me to in the problem as, oh, there it is. It's right there. I just drew over it. 0.911 ATM. They gave me that in the problem. I just drew a red circle over it, though. 0.911 ATM. Down here, same thing. My mole fraction of oxygen times my total pressure. And that's going to give me times 0.911 0.904 ATM, and that's going to give me 0.00728 times 0.911, 0.00663 ATM. And that's it.